This is Neil Schneider for MTBS-TV at GDC 2017. It's going to be an amazing show. To my immediate right is Adam Malamy. Adam is the Vice President of Engineering and the co-founder of NGCodec. Welcome to the program, Adam.
Thank you.
Now, we actually got a chance to try NGCodec out at CES, and obviously there have been even more improvements since we saw it last. Why don't we talk a little bit about what NGCodec is for those that are unfamiliar?
Okay, NGCodec is a startup company. Our primary contribution is a very low latency, high resolution HEVC encoder, which we are applying to the field of VR. And what our significant contribution or our vision, our differentiation, our vision is to do VR not only wirelessly. There are quite a few people attacking wireless VR, getting rid of the cable, but also to be able to do it remotely, cloud VR, where the VR system is not in the same room as the VR headset with the person using it.
Okay, so for those who are completely unfamiliar, normally if I were to use a virtual reality device like this, I'd either A, have a gaming console, which is of course a different solution, or I'd have a PC, or I'd have a smartphone. And each solution has X amount of processing power behind it, and you get the results dependent on that processing power. Right. So what's the advantage of what NGCodec is doing?
So this demo that we're doing here is driven by a top-end PC with a very expensive graphics card in it. And if someone wants to buy that for themselves in their home, it's going to cost them many thousands of dollars. And they're not going to use it all that often, right? They have to eat, they have to sleep. Even the hardest of hardcore gamers is not going to be using his system 24 hours a day. Now, what if you could, instead of having to lay out all that capital for a system, what if you could have a monthly subscription to a service, just like people are used to doing with online role-playing games, where you could subscribe to a service that provided you with VR games or other applications in the cloud for a low monthly fee without having to outlay all that capital. That's the vision. It's tricky to realize that vision, though, because right now you have this large HDMI cable that's connecting the headset to the PC, which is carrying many gigabits of data per second to the display. And obviously you cannot do that over the internet remotely. There are some wireless solutions that are in the market right now for room-based gaming. Most of them use the 60 gigahertz band, there's a lot of bandwidth available. There's some issues with them, and they managed to get a wireless link going that can do several hundred megabits per second, and that can be enough to get you by in a room to do wireless VR. So there's some solutions like that are on the market right now, but you're not going to get several hundred megabits from your service provider to your home. You're going to get 10, 20, maybe these days you can get up to 20. So what do? You have to do what people normally do when they deliver video, which is compress it. And everyone's probably familiar with H.264, today's most ubiquitous form of compression. H.265 or HEVC is the new one, about twice as much compression efficiency.
So again, for those unfamiliar, when we're talking about compression, we're talking about taking raw data and making it smaller. So it's more of it can be transferred through, yes?
Exactly. So whenever you watch a YouTube video or a Netflix movie, you're experiencing video compression, right? The video is compressed at the head end, sent to you over the internet, decompressed on your TV or on your computer, and then you see it. And compression algorithms are very good these days. You can compress, an HD movie or even a 4K movie down to the 10 to 20 megabit per second range, which is something that your internet connection can handle. Now the thing is that when you do that, when you're watching a movie, you don't really care if there's a couple seconds delay from the time that the computer out there on the internet is transmitting the movie to you to the time that you see it in your living room. You don't care about that. But if you're playing a virtual reality game, it becomes very, very important because, as we know, the rule of thumb for virtual reality is that if you move your head and you don't see a corresponding movement on your view screen in about 20 milliseconds, you notice it, and it can actually start giving you vertigo and other nasty side effects. So in order to be able to even think about doing VR system in the cloud, you have two major obstacles, or you have two major challenges that you have to overcome. And one is the latency, and the second is the compression. So this is where NGCodec is focusing its skills and energy. So we have developed an H.265 video encoder that has it gives you the advantage of HEVC compression, and at the same time we've put a lot of effort into a lot of our engineering skill into getting the latency down to a very minimal amount. So we have on our encoder, we have only 1 or 2 milliseconds of latency in the encoding process. And for people who are familiar with this, another very important aspect is the rate control, controlling the bit rate of the generated video. That is also something that you have to be very careful with, and that NGCodec has put considerable time into.
Why is this important? Can you elaborate what the bit rate is, why it's so important?
It's a bit hard to explain, but you can think about, let's say you're trying to transmit data at 10 megabits per second on the average, and you have some of it is 100 megabits per second, but the rest is only 1 megabit per second. The average is 10, but when it comes time to do that 100, you're not going to get it through the 10 megabit per second pipe. It's going to suffer delays. That's when things like that happen, is usually when you see the little buffering wheel spinning on your display, and you're saying, oh, okay, why did my video stop? That's not going to be good.
Is it like a qualitative control of the data?
The rate control?
Yeah.
It is a continuous trade-off between the quality of the data based on what the content is currently showing and controlling for a maximum amount of allowable latency.
Okay. So you were explaining that you've added this control for the bit rate within the technology, and this is important. So
we have. So NGCodec's technology is an FPGA-based HEVC encoder. FPGA is also a very important component of a cloud-based system. These cloud-based systems will be running in a data center somewhere, and data centers these days are just starting, but there's a trend in that direction to add FPGAs into the data center servers to accelerate various tasks. So we rely on that, a cloud server with an FPGA accelerator installed to run our encoder IP at very low latency.
What I'm seeing here is we've got a virtual reality demo running on the HTC Vive. Now, why don't we talk about the demo itself? What have we got going on here?
Right. So the demo itself is basically a complete system using our encoder and a decoder to show how our technology allows you to compress virtual reality content down to a manageable 10 to 20 megabit per second, decode it, and see it on the HTC Vive headset without any perceivable latency.
Okay, so maybe you could walk us through the steps.
So what's happening here is on this PC that's over in the corner here, we have we're running the VR application, and there's a high-end NVIDIA graphics card rendering the display. Also in that same PC is an FPGA card with an FPGA in it, which is programmed with our HEVC encoder IP.
So okay, let's stop there. So the FPGA, that's like a cloud-based distributor? Is that the idea, or a network distributor? How would you describe that?
The FPGA itself is just it stands for Field Programmable Gate Array. It's just a chip. It's a chip that you can program with whatever hardware configuration that you like. So if you could open up this PC and look in the back, you'd see two cards in the PCIe slot. One is the graphics card, and the other is our encoder. So what we do is, As the graphics card renders the game, we capture the frames, send them to our encoder very quickly, minimal latency there, encode them, and the encoding also adds no latency because we've optimized for that. The encoded bit stream is then sent out as it's generated onto the Ethernet, and in this demo, there's supposed to be a Wi-Fi link, but we're having trouble getting the Wi-Fi going in this hotel room, so we actually have the Ethernet coming directly into the decoder. The decoder is not designed by NGCodec. A partner is designing the decoder board. They're a company called VYU Sync, and they also have optimized their decoder under our instructions for minimal latency. The decoder is decoding that compressed image and then driving the Vive display. So it's the format is 2160 by 1200 at 90 frames per second. So that's roughly equivalent to a 4K at 30 frames per second, which is a resolution people are more familiar with. And then, you can't really look at it in this interview, but if you were to look at it, you would see what is being displayed on this monitor here, and you would see that as you move the headset, if you were wearing this, you would see that it would be working properly, and you would not be noticing. The whole key is you're not supposed to notice, right? You would not be noticing that there's an encoder and a decoder sitting in the path.
So I did try it out, and I thought it was very fluid. I didn't really see much in the way of visual anomalies. Like normally when you're dealing with compression, you'd see little pixelizations, showing the little flaws. I didn't really see much of that. What I did notice, and I think it may have to do with the room because of the way the Vive was set up, is just maybe some minor tracking issues. Would that have had anything to do with this, or is that just the nature of the device?
It's probably not anything to do with this. Our system is in development. It's not 100% ready for prime time. It's very close. You may, if you got good eyes, still spot a little glitch here or there, which we're working on removing. So this is, we're at the end of February now. At CES in January, we were displaying this on a 1080p60 head-mounted display. This one is now twice the resolution. So we've beefed up our system to be able to handle the increased resolution and frame rate. And every day we're improving the quality, we're reducing the latency more, and we're working our way towards a real live cloud demo of virtual reality.
As I said, I thought it was very impressive, very smooth, and again, it's a work in progress. And I did see it at CES, and this is markedly better than even what I saw at CES.
Yeah, we got our team of engineers back in Sunnyvale working hard every day to make the system better.
Now, from an end user point of view, I know this is still being prototyped. If memory serves, you've got the network going at between, I think, 10 to 15 megabits per second. Is that practically speaking, what do you anticipate the end user is going to be using, from a receiving end?
They're going to be in that range, maybe even a little higher. So this is not, you do need some pretty high-end network connectivity at your house to be able to make use of this. So if you're sitting at home with like a 1.5 or 3 megabit per second link, which is what kind of the last 5 years ago, that's what people would have. You're not going to be able to do this. You need to be in that 10 to 20. You probably need fiber. You need low latency path to the ISP that's going to be serving you this game. So you do need that. So this cloud VR, is maybe not today for everybody. There are some customers who already have that capability in metropolitan areas, but not everybody. But it's coming. And other countries actually are far ahead of the US in terms of connectivity and bitrate available to the typical end user. So they may actually even be ahead of the game on this.
Okay, well, sounds good. Well, thanks so much for joining us.
Okay, thank you very much.
This is Neil Schneider for MTBS-TV at GDC 2017. We will, of course, be back with more. Thank you for watching.